Hi and welcome to the fifth episode of this video series where we build an application to control a musical instrument via MIDI. Although with the current version of the program we can play sounds on the instrument using the computer keyboard, most similar applications would display an image of a piano keyboard on the screen instead and let the user click on the keys to try out sounds. So now I'm going to add such a virtual piano keyboard to my program. Just like a channel, this keyboard will be implemented as a user control and will feature a couple of other things like octave selection and an all notes off button. I also want to empower the user to make the MIDI device selection instead of having it hard-coded. So let's jump right into it. When I show you the keyboard user control, there is not much to see there. A drop-down list box for the octaves, a checkbox to enable or disable the keyboard, and the All Notes Off button. But the keys are not there because they are built in code. There is only a placeholder for them here. In the code, the keyboard keys are implemented as an array of buttons. There are 12 of them, which covers one octave only. That's why there is a list box for octave selection, so that the scale can be transposed up and down. I declared a new constant here called note number base, and it is the value of the lowest C note number on my keyboard. All other notes will be defined in relation to this number using the scale from C to B and the octave. This is the scale. This is actually C1, equivalent to the note number base constant. As an example, middle C, which is C4, will be C1 plus 3 octaves. The fifth note, which is G on the C major scale, above middle C, is calculated by adding 3 octaves, that is 36, to the value of G here. I also changed the key map dictionary where the computer keyboard keys are mapped to the musical notes. This dictionary used to be in the main window class, but I moved it to this keyboard class. I am now localizing all code that is to do with playing on the keyboard in this class, appropriately called keyboard. And this is true for keys on the computer keyboard and on the on-screen keyboard you'll see shortly. This arrangement is an improvement over the previous design. The semitones and offset variables play a role in constructing the screen image. Here, the keys are laid out nice and neat next to each other. The tag property of a key will have the corresponding musical note number assigned to it. The key as a button responds to mouse click events, mouse up and down events to be exact. Notice that I'm using the preview, that is the tunneling version of these events. You can experiment to see what works and what doesn't. It's not quite what one would expect. The event handlers are pretty straightforward. The trick I'm using on this line is that when the user clicks the right mouse button, I raise the pitch by an octave. The begin play and end play methods come in pairs. This is an example of method overloading. Same function name, different parameters. This one is more generic. This is where the musical note MIDI message is constructed and sent to the MIDI device. This one takes a keyboard key as its argument, figures out what musical note number it corresponds to, and then calls the other begin play method. The calculation is a little bit tricky. The upper keys on the computer keyboard have 1 or 2 octaves built into their note numbers, and they have to be extracted and then added to the octave the user selects in the octave drop-down list box. Basically, this is it for the on-screen keyboard. The rest of the code was explained in previous videos, so if you haven't seen them, go to my YouTube channel and you will find them there. And now, here comes the program in action.